Section 8.4, Adding, Subtracting, and Multiplying Radical Expressions. So to add or subtract radicals, you must have like radicals. What does that mean? Well, like radicals are radicals that have the same index and the same radicand. Remember, the radicand is the thing under the radical. So if we have the same index and the same radicand, we can add or subtract the radicals. But how do we do that? Well, the first thing we want to do is simplify all radicals. So take out anything that can come out. Combine any like radicals. Remember, if adding or subtracting like radicals, all you're going to do is add or subtract the numbers in front, leaving the radical unchanged. So it's kind of like if you had 2x plus 3x. 2x plus 3x is 5x. The x did not change. So the radical doesn't change, just like the variable didn't change. So, add or subtract, assume that variables represent non-negative values. We say that because we don't want what's underneath their square root to be a negative. So we'll just assume that everything is 0 or positive. So number 1, 6 times the square root of 3 minus 5 times the square root of 3. First thing we do is try and simplify the radicals. Nothing can come out. Then we look to see if we have like radicals. Well, they both have the square root of 3, so we're able to subtract the numbers in front. So 6 minus 5 is 1, and we get 1 square root of 3. The 1 is understood to be there, so we'll just write square root of 3. Number 2, 5x square root of 6 minus 3x square root of 6 minus 2x square root of 6. Again, we try and simplify the radicals, but we can't. So therefore, we look to see if we have like radicals, and they are. So we'll go ahead and put them together. So 5x square root of 6 minus 3x square root of 6 is 2x square root of 6, and we still have a minus 2x square root of 6. Well, 2x minus 2x is 0, and 0 times the square root of 6 is 0. So make sure you don't think there's a 1 left over. There's not. 2x minus 2x is 0, and 0 times the square root of 6 is just 0. Number 3, the cubed root of 2 plus 9 times the cubed root of 2. Again, we do have like radicals, and no simplifying can happen. There's a 1 in front of that first cubed root, so 1 plus 9 is 10, and again the radical stays unchanged. So 10 times the cubed root of 2. Number 4, the square root of 48 minus 3 times the square root of 27. First thing we do is we look to see if we can simplify the radical. Well, looking at the 48, let's go ahead and start doing the factor tree. 48 we would break up into, say, 6 times 8. Well, 6 is not prime. 6 is 2 and 3. 8 is 2 and 4. And 4 is 2 and 2. We circle pairs because our index is a 2. So we have a pair of 2's there and another pair of 2's, which means a 2 comes out. Another 2 comes out. But as you can see, there's a 3 left right here. So a 3 is going to be left under the radical. Now, let's look at the 27. 27 is 9 times 3, and 9 is 3 times 3. We circle pairs again. So we have a minus sign. There's already a 3 on the outside. A 3 comes out because there is a pair, and we have left what's underneath the radical is this 3, so we have a 3 left underneath. Multiplying this out, 2 times 2 is 4, so we get 4 square root of 3, minus 3 times 3 is 9, so we get 9 square root of 3. 4 square root of 3 minus 9 square root of 3 ends up being negative 5 square root of 3. We're allowed to subtract those radicals because they are like radicals. Number 5, 2 times the square root of 50x squared minus 8x times the square root of 18 minus 3 times the square root of 72x squared. First things first is we have to try and simplify our radicals. Well, 50 is 25 times 2. And 25 is 5 times 5, so we have a pair of 5's. There's already a 2 on the outside, so we have a 2 times a 5. Leave a little bit of space because we'll work with that variable, and what's left underneath is that 2. Now, power divided by index, that means we have 2 divided by 2, which can go one time with the remainder of 0. So an x comes out, and no x's are left underneath. In the second one, 18 is 9 times 2, and 9 is 3 times 3. So we have a negative 8x on the outside, a 3 comes out, and a 2 is left underneath. Next radical, 72, we'll say is 36 times 2. You could also say 9 times 8. 36 is 6 times 6. I'm going to stop there because I already have a pair of 6's. So we have a 3 on the outside, a 6 comes out. Leave a little bit of space because we'll work with that variable, and this 2 is still left underneath. So same thing with this variable, power divided by index. My power is 2 divided by 2 can go one time with a remainder of 0. So x to the first comes out and no x's are left underneath. So now we'll multiply. 2 times 5x is 10x squared root of 2. Minus 8x times 3 is 24x squared root of 2. Minus 3 times 6x is 18x square root of 2. Now looking at the radical, we see that they are all like radicals, so we'll go ahead and put all these together, adding or subtracting the numbers in front. So 10x minus 24x minus 18x would give me a negative 32x square root of 2. Now number 6, you'll see it's a cubed root of 81 plus 3 times a cubed root of 24. So be careful when you do the factor tree. You're looking for, in a sense, triplets. Well, 81 is 9 times 9, and 9 is 3 times 3, and the other 9 is 3 times 3. So we do have a triplet. So 3 comes out. Don't forget your index of a cubed root, and what's left underneath is that 3. So on the next one, we have plus. 24 is 6 times 4. 6 is 3 times 2, and 4 is 2 times 2. So again, we do have a triplet. There is a 3 on the outside, so the 3 is on the outside. It's going to get multiplied by 2. Don't forget the index of a cubed root, and what's left underneath is this 3. So multiplying out what we can, this is just 3 cubed root of 3, plus 3 times 2 is 6, and we get 6 cubed root of 3. Now that we have like radicals, we can put those together, and 3 plus 6 is 9. Radical does not change. So 9 cubed root of 3. Number 7. 7 times the cubed root of a to the 4th b cubed c squared minus 6ab cubed root of ac squared. Well, definitely don't have like radicals, so let's go ahead and start trying to simplify. Well, a to the 4th, we have a power of 4, and divided by the index of a 3, it can go one time with a remainder of 1. So the 7's on the outside, and a comes out, leave a little bit of space, and then a is going to be left underneath. Now what about the b? The b has a power of 3, divided by my index of 3, it can go one time with a remainder of 0. So one b comes out, no b's are left underneath. Now if you look at the c, c only has a power of 2, so they don't have enough to come out, so c squared will stay underneath. For the next radical, we have minus 6ab. Looking at what's underneath the radical, a only has a power of 1, and c only has a power of 2, so nothing's going to come out. Do we have like radicals? Yes, there's the same index with the same radicand, so all we got to do is put the numbers in front together. So 7ab minus 6ab is 1ab. Radical does not change, so we leave it as a cubed root of ac squared. Don't need the 1 because it's understood to be there, so we will just box in ab cubed root of ac squared. Now let's find the product and simplify if possible. Assume that the variables represent non-negative values. So how do we multiply radicals? Well, we multiply the numbers on the outside, and then we multiply numbers underneath the radical. But never multiply a number outside underneath. It's always outside, outside, inside, inside. So for example, number 1, we have the square root of 5 times 4 minus the square root of 5. So when I distribute the square root of 5, there's really a 1 in front of that square root. So the 1 and the 4 get multiplied, and I get 4 square root of 5. Minus the square root of 5 times the square root of 5. Since they're both having an index of a 2, we can multiply the 5 and the 5 underneath. So square root of 5 times the square root of 5 is the square root of 25. Looking at 4 square root of 5, there's nothing we can do with that. Minus the square root of 25, we know is just 5. Those are not like radicals, so do not put them together. You are done at that point. A lot of students want to put those together, but they're not like radicals. One has a radical, one doesn't, so they do not go together. Number 2, the square root of 7 times the square root of 5 minus 3 square root of 14. Again, distributing, because we have a square root times a square root, we can multiply the numbers underneath, so 7 times 5 is 35. Minus the 3's on the outside, so the square root of 7 times the square root of 14 is the square root of 98. So now we look to see during the factor tree. Square root of 35 is 7 times 5. There are no pairs, so that one's going to stay as is. Well, 98 we know is 7 times 14, and 14 is 7 times 2. So we do have a pair of 7s. So a 7's going to come out. What's already out there is a 3. So we have the square root of 35 minus the 3 is already out there, the 7 comes out, and a 2 is left under the radical. So just multiplying the 3 and the 7, we have our final answer. Square root of 35 minus 21 square root of 2. We can't do anything with those because they're not like radicals, so we are done. Number 3. In parentheses 5 minus the square root of a times in parentheses 2 plus the square root of a. So this is a binomial times a binomial, which means we need to FOIL it out. 5 times 2 is 10. 5 times the square root of a. Well, the 5 stays on the outside, square root of a stays on the inside. Now distributing this negative square root of a. Well, there's a 2, and again there's a 1 in front of the radical, so minus 2 square root of a. And negative 1 times a positive 1 is a negative 1. Square root of a times a is a squared. We're allowed to multiply those because they are underneath the same index. Is there any simplifying we can do? Well, here we have a 10. The middle ones are like terms. They both have the square root of a, so 5 minus 2 is a 3. So plus 3 square root of a. Minus, on the last one, we do have the power rule, which says we can take 2 divided by index 2, and 2 divided by 2 is 1. So an a is going to come out, and no more radical is left. Looking at that, there are no like terms to combine, so we are done. Number 4. Square root of 5 plus the square root of 2 times the square root of 2 plus the square root of 7. So we'll distribute. Square root of 5 times the square root of 2, they're both underneath the same index, so we'll multiply those and we get 10. Square root of 5 times the square root of 7 is the square root of 35. Square root of 2 times the square root of 2 is the square root of 4. And the square root of 2 times the square root of 7 is the square root of 14. If you try the factor tree on the 10, nothing can come out, so it stays the square root of 10. Same thing with the square root of 35, so plus the square root of 35. Plus the square root of 4 is 2, so that radical disappears. Plus, and the square root of 14 cannot be simplified either, because 14 is 2 times 7, and there are no pairs. Looking at that, there are no like radicals, so that is our final answer. Number 5, we have another binomial times a binomial. In the first parentheses, we have 8 square root of 2 minus 2 square root of 3 times 2 square root of 5 plus 3 square root of 10. So we do need to distribute. Remember, numbers on the outside get multiplied by numbers on the outside, and numbers underneath radicals get multiplied underneath. So 8 times 2 is 16, square root of 2 times 5, which is 10. 8 square root of 2 times 3 square root of 10, well, 8 times 3 is 24. And the square root of 2 times the square root of 10 is the square root of 20. Now let's distribute the negative 2 square root of 3. Well, negative 2 times 2 is a negative 4. 3 times 5 is 15, so we get negative 4 square root of 15. And lastly, negative 2 times 3 is a negative 6. Square root of 3 times 10 is 30. So now we'll need to do the factor tree to see if we can simplify into the radicals. Well, 10 is 2 times 5. No pairs, so we'll leave that as 16 square root of 10. 20 is 4 times 5, and 4 is 2 times 2. So we do have a pair of 2's. And there's a 24 on the outside, so we'll have 24 times 2, and the 5 is left under the radical. 15 is 3 times 5, no pairs, so we'll leave that as negative 4 square root of 15. And 30, if you do the factor tree, nothing can come out of a 30 either. So the only one we could have simplified was the square root of 20. So multiplying that out, we have 16 square root of 10 plus 24 times 2 is 48 square root of 5 minus 4 square root of 15 minus 6 square root of 30. There are no like radicals, so you're done. On number 6, we have the cubed root of 9 plus 5 times the cubed root of 9 minus 2. We'll start off a binomial times a binomial, so we'll distribute. Cubed root of 9 times the cubed root of 9 is the cubed root of 9 times 9 is 81. The cubed root of 9 times a negative 2, well, the 2 stays on the outside, radical stays unchanged. On the inside, 5 times the cubed root of 9 is just 5 times the cubed root of 9. And 5 times negative 2 is negative 10. So now we'll try the factor tree to see if anything comes out. 81 is 9 times 9. Don't stop there. 9 is 3 times 3, and 9 is 3 times 3. So we do have a triplet. We're looking for a triplet because our index is a 3. So a 3 comes out. Don't forget your index of a 3, and a 3 is left underneath. Looking at the middle terms, we do have like terms there. So negative 2 cubed root of 9 plus a 5 cubed root of 9 turns out to be a 3 cubed root of 9. Adding or subtracting just the numbers in front, leaving the radical unchanged. And we still have a minus 10. So now we look to see if there's any other like radicals. No like radicals, so that's our final answer. 3 times the cubed root of 3 plus 3 times the cubed root of 9 minus 10. So number 7, we end up with the square root of 5 minus 3 quantity squared. Remember, we can't square pieces because of the minus sign. So what do we have to do? We have to write the binomial twice and FOIL it out. So it's going to be the square root of 5 minus 3 times the square root of 5 minus 3. So we'll start distributing. Square root of 5 times the square root of 5 is the square root of 25. Outer gives me negative 3 square root of 5. Inner gives me negative 3 square root of 5. And last gives me a plus 9. The square root of 25 we know is 5. The middle terms are like terms. They don't cancel each other out. A negative 3 and a negative 3 give you a negative 6. Radical stays unchanged, so square root of 5. And we still have plus 9. Now we look at the 5 and the 9. Those can be put together. And 5 plus 9 is 14. So we have 14 minus 6 square root of 5. Be careful when you are having a quantity squared. Write it twice and FOIL it out.